Okay. Hi everyone, I'm Riccardo Amadio. I come from Italy. I'm a data engineer at Agilab. Agilab is a company that makes big data mesh, elite data engineering. What we say it's data engineering is just not a little rule, it's a big rule. So we try to make a big data architecture for company. We also have a product is with Boost that create a data mesh solution. Yeah, remote work, yes, as always. So today we will talk about a very simple pipeline, a data manipulation pipeline. It's everyone that works with data science, machine learning, data engineer, they make pipeline. So it's normal-based data pipeline. So you start with a data ingestion, we make data manipulation, and we make serving. So we extract the data, load it in a SQL DB for Tableau or stuff like this. We want to use a modern data stack. We are in 2023, and it's cool. It's so cool to use cool technology. So we use Snowflake for the data warehouse, data storage, computation, dbt because it's a SQL. It's very easy to take. We can just say to the business analytics to use it because they know SQL, and they have many plugins for data manipulation and stuff like this. Airflow because it's a pipeline orchestrator. But imagine that you are the data engineer or stuff, whatever you are doing, your role. And the manager say, okay, the consumer say that the data quality is not consistent, the data is not good, there are some fail, there are some error, there are something the data engineer is do. This is the daily job of a data engineer, normal day. So what do? We have different tools. We have Snowflake. You check the data on the Snowflake from the data source to the staging layer, silver, bronze, gold, everything. You check dbt logs on S3 or dashboard or whatever you want. You check it and analyze. You go to Airflow. You check where the pipeline fail. You go to the logs of Airflow and CloudWatch or whatever, Grafana, whatever you want. If the Airflow web interface it works, sometimes it doesn't work. So many tools, too many. It's burnout. We will go in burnout every day if we go in this direction. So there is a problem. There is a problem to define what is a pipeline and what is a data pipeline. So a pipeline orchestrator, it's a pipeline orchestrator. It's just execute commands, task, function, nothing especially, just task. Just if you want to make a Linux or deployment, it's a pipeline orchestrator. Okay. ETL or data integration, I just aggregate it if someone had to, don't be shy with me. ETL are design partner framework, like Pandas, for example, Spark, or whatever you want. Talend is a data integration tool, so you can create pipeline, move data from point A to point B, transform it, etc., etc. Airbyte, the same things. Data pipeline, it's a different sub-concept. It's a different concept because we want to understand what happened on the data. What is the transformation of the data? We want to also to come back to make backfills maybe. We want to partition the data. We want to understand which is the life cycle of the data. Okay? So we have Dagster and we have Luigi. So I just explained it, Airflow, they have many problems. If you just go to Hacker News, there is an issue open with 1,000 comments of I have a problem in production, the web interface is not working, can scale the Airflow, etc., stuff like this. And from my experience, there is also a problem in how to use Airflow. I mean, there is an operator. Someone is contributing in this operator. I don't know which one is contributing. It's who is the maintainer of the operator. I don't know. Maybe Airflow, maybe the integrator. I don't know about this. There is an operator, but many of times we do custom operator because it's difficult to handle. This is perfect. That is a good solution for pipeline. It's not for data pipeline. It's like Airflow, it's like Jenkins. You can execute commands on Linux, execute function, Python function. It's a good solution, but it's not for data. There are no way to handle metadata or lifecycle of the data. Luigi is a good solution created by Spotify. There are not too much maintenance, as I've seen. When I choose to go to Dagster, it's because there are not too much maintenance, not many teams and companies that use it, but it's a good solution if you want to check it. So let's compare Airflow and Dagster. So Dagster is focused on assets. Assets, it's what the data engineer want to focus. The transformation of the data is inside the asset. Assets are data, are table, data frame, whatever you want. But it's our focus. Dagster, it has also a development life cycle. So you can create unit testing, you can create continuous integration, you can separate the dependencies of every pipeline you create. In Airflow, it's a bit difficult to do. We deploy the stuff that it's horrible for separated dependencies. We can debug, we can separate the staging environments, everything about this. And there are many different kind of deployment for Dagster. Whatever you want, Kubernetes, Docker, AMR, everything. So let's maybe take a look at Dagster, maybe. So, why? Okay. Yeah, this is a normal asset definition in Dagster. So we have 2-3 things to talk. Okay. First thing, declarative pipeline code. It's finally that we can create pipeline with clean code, without spaghetti code, stuff like this. Declarative code with asset, with just declaring the parameters and the parameters and also the ints. It means what are you searching. If the data source is the table and the database X on the table B, you can declare here. You can say, okay, the database is there, the source is there, and the schema is this. You can create the dependencies. So you define an asset that have another asset as a dependency, and you can run this asset without the dependency before. You can create multiple dependencies. And the assets, it's just an object that is stored in a storage, wherever you want. S3, SQLite, SQL, whatever you want. Asset is just an object. So you can do an asset for your machine learning model. You can data frame, your DBT model, whatever you want. So where is the magic? Where is the magic in Dagster? For my opinion, it's IO Manager. IO Manager is where the magic happens. Dagster have many, and we will see it later, that many IO managers are already created, like BigQuery, Snowflake, Databricks, Redshift, Spark, Pandas, everything. So you can handle all the data that you want, all the data sources that you want. Just take the IO manager provided by Dagster, just pip install, and it's fine. But in my opinion, If you want to create different data source, different data serving and stuff like this, you can create your I/O manager. And it's very easy. There are two functions that is important: handle output and the load input. And inside there, you can specify your dynamic partition, partitioning of your assets, multiple sources, FTP, SSHA, request to API, whatever you want. You can retrieve the data from different data sources. And the special things is that here you can define the metadata. The metadata is what we want to see on the dashboard. The metadata is what, for example, the schema, the columns that we ingest from the table. So maybe today the table ingests 6 columns, tomorrow it's 7. So the manager say, what happened? In Airflow, I can say, in Dagster, yes. So in the dashboard, I can show the metadata. I can customize the metadata. If I want to show the weather in San Francisco, I can say, I can just write. And I can also cache it, store it, whatever you want. And also here, I can also customize it a little, the data source type. So if we want to have different data sources like Pandas and Spark in the same I/O manager, we can specify the key on the asset. We just define on the asset here, on the declarative, the key. So whatever, for example, SQL type, Postgre, or MySQL, we can specify here, and after the I/O manager, it will handle. So a good thing is that we work with big data. So big, it means terabytes of data. And if you want to handle terabytes of data, you need to partition your data. So it's very important for us. In Agile Lab, but in every company that works with Spark and stuff like this. And for this reason, we need to partition the data, and the asset can be do. So an asset can be run for one partition, or for each partition, or for a range of partition, bucket. You can bucketing also your asset by partition. You can schedule a job by using an interval of partition, for example. So imagine that you want to run the asset only for today and tomorrow. So the asset run only for these 2 days partition. We can create job partition. So we can define the partition not only for one asset, that it's just one table, just one object, but for multiple assets. And we can handle also multi-dimensionality partition, so like time and location, for example. So as I explained before, what I choose when I choose Dagster is the declarative. So it's very easy to understand here which is the input of this asset and which is the output of this asset, okay? And you can see it from the dashboard. You can see what's going on the pipeline, on the job, on the asset. You can see in every layer of your transformation what happened. In the dashboard, you can debug your pipeline. You can materialize your asset. Materialize it means that you run the asset and it persists the object on the storage. The storage is completely whatever you want, as explained. In the dashboard, you can see the partition that you are running, everything. There are some things about Dagster, also in the last release, about graph. From the team of Dagster, there is a suggestion to, if you want to use many assets, multi-dependencies, stuff like this, it's for suggestion for scalability of the Dagster. It's better to use graph. It's a library inside Dagster to handle multi-asset and multi-graph. So materialization, backfilling, and sensor. As I explained, the materialization is the concept, is the event that trigger the asset. So you run the asset, or maybe the asset already have a storage with already the data loaded, everything, and you don't need to reload it. So you can use cached data. It's you can customize it, you can do it as you want. Sensors are events. So you create sensor, for example, if you want to understand, if you want to run a pipeline every time there is a new release of a software, yeah, you just make a sensor. This sensor run every 30 seconds, every one you want, and check if this SQL data is updated or the API is updated, whatever you want, and you can launch the asset or the pipeline. Backfilling for partition or subset of partition. So when you materialize the assets, you want also to maybe come back because the data is wrong today, because the data source is wrong, so you want to come back. What do? You can do backfilling for specific partition or a set of partition. So in Airflow, you can do this. Job and scheduler, that it's what it's in common with the pipeline. Job are the aggregator that take all the assets. So you define assets, you define the dependency by assets, and you associate these assets to a group of assets. This group asset can be passed to a job to create a job. The job is the thread that is rule is to start the first asset, choose which are the dependencies, and the scheduler of the asset. And so the job can be launched in a different environment. So imagine that we have a server here, and we have a server in another country. We want to launch the pipeline here with a set of partition, and there with another set. With the run launcher and job you can do. So you can run the job in different servers, different environment, by using the same code. So we are not defining different code. The same code, just say, okay, run launcher, Docker, or HES, or AWS, whatever you want in another server. The scheduler, the scheduler, it's the main rule of the scheduler is to create the rule for cron for schedule the job. So if you want to run it 20 times in a day, you can do it. There is a policy that you can create for schedule the pipeline, the job in a dynamic scheduling. So for example, if you want to launch the job, as I explained before with a sensor, you can do it by defining this policy. Deploy and gRPC. As I explained before, you can deploy the pipeline in different servers and run it in different countries with different data rules, privacy, and stuff like this. How we can do this? By two concepts. The repository. Repository is where your pipeline is located. Workspace is the older pipeline and older repository place. So the workspace is it's not the repository in GitHub or GitLab or whatever you want. Workspace is the repository for all the pipeline of your company or your team, for example. Repository instead is just for your pipelines. So I create pipeline, Stefan will create other pipeline in another repository, in another GitHub repository. And we can separate the dependency. So I have a dependency, Stefan have another dependency. So we can work independently. We can do it by using the gRPC server. So the gRPC server just connects the workspace to the location of the code of your repository. So my code is in GitLab, your code is in GitHub. So the gRPC just connect into different and take the code from there. So as I explained, there are launcher. It's a launcher that launches the code, the pipeline, whatever you want. And so the magic things of the modern data stack. Dagster started their project by defining that they want to use a modern data stack. And so DBT. DBT is the first integration that they created. So with DBT, you can create easily data manipulation pipelines. And this is the goal of that data pipeline, to monitor the data, the life cycle of the data. So Dagster have an integration with DBT. You can use DuckDB, or you can use whatever you want to run it. You can choose. Or you can do your I/O manager and handle all the data source, writing, getting, everything. And yeah, there is this method that's very easy to take it. Dagster have many integrations. Airbyte, Fivetrain, Dagster, Spark, Twilio, whatever you want. They release integration every release or stuff like this. So now they have, for example, a new integration with weight and bias for track the life cycle of the model. It's not like MLflow, but it's similar stuff like this. You can register your model, stuff like this. Thank you very much. Thank you for your attention.
So big round of applause for Riccardo. Yeah?
Yeah.